you actually should have time tonight, because this worksheet that we're going to do with C1, it's not due really till Friday. And since I'm gone Friday, probably Monday, right? So it's not like it's hard stuff that you have to take a look at. Did you get it? Did you get it? Oh, dang. It's been flying around all day. All right, so this is what we are looking at. We're going to be working with exponents in this unit. I'm going to have you set your guys' stuff underneath your desk. Grace, you too. Thank you. So in this unit, we're going to be learning about exponents, scientific notation. Today, we're going to start just with exponents. So when I think about exponents, and I write this down, 3 to the second power. What's the exponent?
2.
The 2. So my exponent, I know, is 2. Okay? What does that 2 tell us? What are they used for? The 2 tells us what? Isaac, what? How many times that number is multiplied? So, what are exponents used for? Exponents, right? Tell us how many times, when we're looking at it, and when we're thinking about that, it's how many times that what? How many times that you multiply. And what is that lower number? Anyone remember what that's called? It's called our, how many times you multiply the base number. How many times you multiply the base number? By itself. Nice. I like your adding to my definition. By itself. So, in that this one, so this is our base number, right? And if we are looking at that, 3 to the second means taking 3 times itself twice. So if I had 3 to the 4th power, that means I should have 3 times 4 times, right? That's what it's telling me. The 4 is telling me that I need to see 3 4s being multiplied, okay? So kind of just that basic definition of what that is. So writing this down so you have this same thing in yours. Now, the next part down is looking at the vocabulary for this that we just kind of put up here. In that they already said the exponent. So the exponent is which of these 3 that we are looking at, first, second, or third one. The number of times the base is being multiplied, right? That's our exponent. That's what you guys just told me. The number that's being repeatedly multiplied is our base number. That's the 8 in this case. And when I talk about writing something as a power, like tonight's homework, you're going to see, that's this whole thing, 8 to the 3rd. Okay? So when I'm looking at a power is a way to represent it. It has both the base and the exponent. So if you turn in your notes, I have pens or pencils right over that way, so we'll grab one. There's pens in the back by my desk. Just grab a pen, put it in the house so you don't have to sharpen the pencil. Okay? All right. So if we are looking at this, okay, so you might want to look at your shoulder partners and get their information, okay? So looking at both the exponent, the base of power, and again, if you come in without a writing utensil, please grab a pen from back here or a pencil so that we can keep moving. So we are going to look for, in the top of the next page, some patterns. So it says complete the table for patterns in multiply. Now, expanded expressions, what that simply means is showing the multiplication. So 2 to the second, we just said that means 2 times 2. I need you to write it out this way. Keep your, just write down what I'm saying. Don't say anything yet, just write. So 2 to the second means expanded expression, means I want to see all the 2's were multiplied. 2 to the 4th means I should have 4 2's. Okay. So this was my 2 2's, this was the 4. So it says, well, how many factors do you have? We had 6. Factors are what you multiply together, right? So it says, well, what's the product as a power? So 2 to the 4th and times 2 to the second gives us 2 to how many? To the 6. Okay. So now we're going to go down to the next one, and we're looking at 3 to the third, right, times 3 to the first. Now, a lot of times you're not going to see this. They're not going to put a 1 here. So you want to write at the same time as we are. So a lot of times they won't have anything here. It'll just be a 3. It means to the first power. Okay, so I want you right now to write out all your expanded expressions going down. So do that right now. So the 7s, right? Do it with your x's. Do it in the last one with the x's and y's. Do that right now on your own. So those of you that like to use x for multiplying, I'm really going to try and get you away from doing that. Just because when we are looking at these, you want to use a dot instead of the x's. Because like if I use an x between here, and then this one has x's in it, right? So trying to get away from that and use just a dot. Sometimes you have to, I get it. So in the second one, as we are taking a look, how many factors do we see? Should be 4, right? How many factors of 7s do we see? 5. How many x's do we see? 7. So now we're going to go over to this product as a power, and we are going to write 3 to the 4th would be our answer. Now, we are not evaluating it, right? We're not putting in that that's equal to 81 on our calculator. We're just leaving it as a power, same in your homework. So this will be 7 to the 5th. This would be x to the 7th. But this last one, what you actually have for the number of factors is you have 2 x's and you have 3 y's. And this last one is special, and that your answer is x to the 2nd and y to the 3rd. What was different about all the ones before that? What did you notice about the bases in the first 4, Cassidy? What did you notice about the bases in the first 4 of these going down? The base was always what in each problem? So the 3 to the 3rd, 3 to the 1, 2 to the 2nd, 2 to the 4th.
Oh, they were all the same number.
So it's the same number as our base, right? So when the base is the same, what do we get to do with our exponents? 2 to 4 to get 6, 3 to 1 to get 4, 2 and 3 to get 5, 6 and 1, we add them, right? So this next part down in bottom page of this page of notes, I'm going to have you, as you take a look at this, it says this, except for the last row, right? Except for the last row, what do? We add exponents in the original problem to get the last column. Except for the last row. The last row doesn't work because the base powers are not the same. So in that box on your page right there, that's what you're writing in, right? How are the numbers in the first column related? What pattern do you see? Except for the last row, the pattern is we add the exponents from the original problem. So the other thing I'd like you to write with this is that when we multiply like bases, we will add the exponents. And later we come up with what's called the algebraic rule of this. Okay, so that was that box right there that you're filling that in. So this was what was inside that box. This simplifies it a little more, but that last one was special, right? Question. Yeah.
Would you be okay if you switch spots? Could you take your stuff?
I'm going to have you take all your stuff and we'll see. I don't know if this will work, but we'll do this for today and we'll check from there, okay? Anyone else does have problems seeing? I saw some squinting out there. Did you guys do eye checks? Yeah, no?
I did, but the thing kept saying like negative and positive.
All right. So you might want to, you're really struggling, let your parents know that you can't see the board, okay? So as we're looking at this one. All right, so that's our rule, so everyone should have had that written in, right? Except for the last row, we add the exponents in the original to get the last row. The last row doesn't work because the bases were not the same. So we have 10 to the 4th, and this would really be 10 to, there's no number there. We're going to put a 1 in. Anytime there is no exponent, you can always put a 1 there. Now, I know that when you go to do these in your homework, you're not going to show these rules, but as we do it up here, I want you to at least write the rules down. So the rule said, if the base is the same, our base is the same, we're going to add the exponent. So put 4 plus 1, right? Because that was my exponent. So that gives me as a power 10 to the 5th. And it says, leave your answer as a single power. We are not putting this as a 1 followed, we're not evaluating it, right? So 5 to the 2nd, 2 to the 3rd. Is it possible? Not possible. And the reason is we do not have the same base, right? Not the same base. So we have v to the 8 and v to the 3rd. And I agree, in your homework, I am probably not going to see you writing this. I am probably not going to see 8 plus 3. I want you to put it in your notes so that when you look at it and you go, oh yeah, what do I have to do? And you go 11, that is the answer, v to the 11, right? Some of you haven't written anything as we're doing this. I need you to do these right here. There you go. And then that last one, we have 8 to the 5th and c to the 2nd. And again, we would say what? Not possible. Does everyone agree?
Yeah.
We cannot say AC to the 10th, right? This is not possible. If you do not have the same base, and I'll always have people kind of try and make up something in like AC to the 7th, or no, you cannot do that, okay? So you just got to be kind of careful with that. All right. So top of the next page, we look at division. All right. I want you to make sure, check. All right. So, expanded expressions, right? So, put your fraction bar, and as we look at our fraction bar, how many 2's should I see on top? 8 2's and 3 2's on the bottom, right? Do the next one, put your 3's. When you do the third one down, I need those to be in parentheses, okay? So there's a big difference if you use the parenthesis or not. So this first one, yep, 1, 2, 3. All right, I'm showing the 8 2's over 3 2's. I'm showing my 5 3's over 3 of them. I want to keep this as a -4 times -4. I want to keep the parentheses here. And someone said to me, what does it matter if we have parentheses or not? And here's the big difference. If I take -4 without a parenthesis to the 2nd, that's -16, because that means that I took negative and then I took 4 times 4. And that's how we get -16. But if I put it in my calculator and I put -4 to the 2nd, that's a different answer because that means -4 times -4, which is positive 16. So that parenthesis, it seems like, yeah, it shouldn't be that big of a deal. It kind of is. And then our last one, we have 4 x's on the top, right? And 3 2's on the bottom, or 2 3's on the bottom. Okay? So, if I look at 2 divided by 2, what do I know 2 divided by 2 is equal to? 2 divided by 2. 1, right? So I can cross off. Does it matter which 2's I cancel?
No.
Nope, I can cancel them anywhere. 2 over 2 is the same as 1. Same thing here. Same thing here. If yours lined up at the beginning, cross the ones right at the beginning. How many factors are we left with? How many
5.
2's? We are left with 5. And Cassidy, hang on to it. Just write it down. Don't say it. Just write it. Okay? I appreciate your participation. Just say it. So then go to the next one. Or just write it. Don't say it. My fault.
Minus the 3
So here we're going to have 2 of them. Right? -4 over -4, that's the same as 1. -4 over -4, here we have 1. And this one is an exception to the rule, right? So what's our rule? If we're looking at it, this one's going to be 2 to the 5th. This one's going to be 3 to the 2nd. This one, -4. We're going to keep the parentheses. So same thing in your homework. If it has a negative number in that, and I would take to the first, or I would just take -4. Because it's understood if we don't put a number there that it's always a 1. And then the last one is we're going to say that there were 4 x's, right? And there were 2 3's for our factors. And that stays as x to the 4th over 3 to the 2nd. So, talk to your shoulder partner quietly and think, what do you think the rule is for dividing? How did we get from 8 and 3 to get 5? How did we get from 5 and 3 to get 2? 3 and 2 to get 1? Okay? Talk to your partner right now. You have to talk to them. Okay, you already decided what it was? You both agree? So except for the last one, right? So we can start that the same. Except for the last row, right? What's the rule? Subtract the exponents to get the last column, right? So the pattern doesn't work for the last row because the bases are different. So, how could we say the first and last related? We subtract exponents. So if you even kind of want to go with what I highlighted up there, you don't have to write every single word. And the key is when we divide, right, like bases, when we divide with like bases, we are going to subtract our exponents. When we multiply, we add our exponents. When we divide, we subtract our exponents. So we want to use this to help us with our last few questions down below. Okay? So again, subtract. Key thing I need for you to put down, subtract the exponents in the original, you get the exponent in the last one. Dividing with like bases, we subtract exponents. Our last row is an exception, right? So, again, it says, write the quotient. Quotient means answer to the division as a single power. So when I see this word power, that means I want base and I need an exponent. That's what that means. Anytime I read that in my homework, I want to have a base and an exponent. That's what that tells me. And then it says, use the pattern if possible. So we're going to start off. And our pattern says, oh, we have like bases, right? Like bases dividing. I'm going to take 3 and I'm taking 6 minus 2. Those are my 2 exponents. And I get 3 to the 4th. And I'm leaving it as a power. This 9 is to what power? 1. So I'm taking, this is equal to 9 to the 3 minus 1. Now again, in your homework, do I need to see you writing that? No. As you get to further on in this unit, you're going to actually just do that subtraction. But sometimes it's really helpful. And this is going to give us 9 to the 2nd. Here we are looking at m to the 5th minus 3, m to the 2nd. Y to the 4 over x to the 3, xy to the 1st. Do you agree? No, not possible. This is simplified. So if they ask you to write it in, as a single power, you can't write it as a single It's a y and an x. They're different bases, okay? So, turn your workbook, and then I want to talk about what I have up on the board up here, which I'll leave up here for tomorrow. But turn to the workbook to the first page. There's a difference if the exponent is outside the parenthesis or not, right? This means how many in number 3, how many 4x's should I write? 2 of them, right? Whereas in number 1, we are going to write number 1, so let's do number 1 together. We're going to write number 1 as -2, and then how many x's in expanded form? 2 of them, right? And then we have a 5, so times 5, and then how many x's? 4. We don't need to have the parentheses, right? We're doing an expanded form, okay? This part says rearrange. And when we do the next 8 to 11 down here, I'm really concerned that you kind of do it in the same way. Write it out expanded, then rearrange. So what does my rearrange look like? That means I want to put like all my numbers together, all my x's, then all my y's, okay? So like terms together. So we're going to write this as -2 times 5, and then I have how many x's following that? 6. So if I'm writing my answer, I don't leave it as -2 times 5. -2 times 5 is -10. And now I have x to the 6. The difference here is this is -3x. How many times should I see that?
3.
I should see -3x 3 times. And when I rearrange it, I'm going to see like -3, -3, right? -3. So when I go to do, and some people are totally done with that B in the review, but when I go to look at this, you need to kind of show me the rearrange. So like here I have like the 5 and the x. So I might start with the 5 and the x times 2, and then I might rewrite it as 5 and the 2, and I go, oh, that's going to give me x to the 4th, and then give me your answer, right? But people were getting confused as they got to number 10 because they said, oh, should I write 3x 3 times? No. The 3 is there, and the x was to what power? That's to the 3rd. And if you wanted to write it out at 3 times, but then how many 4x's do I need to have? How many 4x's does it tell you? I need that whole thing 4x written. So that might help you when you're checking the answers in the back. Okay? So, as you are looking at this, making sure as you're showing your work, again, the notes are attached on the daily planner if you didn't get them all. This worksheet not due till Friday, right? And actually, with me being gone, Monday. Okay? So what I want to look at right now is, in Unit B, I want to look at those, any other questions from your review of your test. And in particular, I want you to look up here at the board, and as you look at